Hey guys, welcome to this session on naive-Bayes classifier in Python by Intellipaat. Naive-Bayes is one of the most popular classification algorithms that is being used to build classification models, but it could be a little difficult to understand how it works, especially given all the jargon that surrounds the naive-Bayes classification algorithm. So keeping that in mind, we've come up with this session to help demystify what naive-Bayes actually is and how it works. We'll also take a look at the hands-on and tackle real-world problems in order to understand how you can use naive-Bayes to solve them. So without further ado, let's take a look at the agenda. But before we begin, click on the subscribe button and click on the notification bell icon so that you never miss another update. Also click on the like button if you like our content and put down into the comment section what else you would like for us to cover next. Also, in the meanwhile, if you have any questions regarding any of the topics that we're covering, put them into the question box and our team is there to help you out with any query that you might have. And if you do not understand something that we are teaching here or some of the code that we show you is a little difficult for you to grasp, don't worry. At the end of the presentation, we'll guide you through some of the resources that can help you out with this. So let's take a look at the agenda for the session. We begin by taking a look at what is naive-Bayes classifier. Since that is the bedrock of what we're trying to discuss, we'll begin by making sure that everyone is on the same page. Then comes understanding conditional probability. It is one of the core concepts that surround naive-Bayes, so we'll try and understand what conditional probability means. Then we'll have a naive-Bayes example in which we'll try to solve a very famous problem that naive-Bayes is able to solve. We'll try to understand how that works. Then we'll have a look at the use cases, or we'll try and look at where naive-Bayes has been used and has been effective, so as to understand how effective is naive-Bayes algorithm and why it's so popular. Finally, we'll have a hands-on in which we'll be implementing the naive-Bayes algorithm to solve a problem using Python. All you would need to follow along with this hands-on is a Jupyter notebook and Python installed, and you would need access to a particular data set. But don't worry if you don't have it, you can still follow along with the code, and at the end of the presentation, we'll guide you through the resources through which you can learn everything that we have taught you in this session. So let us begin. We begin by taking a look at what is naive-Bayes classifier. So the naive-Bayes classifier is a supervised learning classifier that performs classification by using conditional probability based on a given data. So as you already know that naive-Bayes classifier is used for machine learning purposes, but it is especially useful to understand that it is a supervised learning classifier, meaning that when we are training our model, we should have some data set that has some features and a target feature. So for instance, if you're trying to train a model to detect dogs in an image, then you should have images, which is your data, and the labels are going to be binary labels of yes or no, describing whether or not there is a dog in the image. Using that, our naive-Bayes classifier can learn how to detect what a dog is if they are missing in some images and are present in other images, and then given that information, they can predict or classify images that come to them. So it uses all of these probabilistic jargon, but it's a little important to understand how it works. So we'll take a look at that in a moment. It is a supervised learning classifier that performs classification by using conditional probability. So it's not just probability, but conditional probability, which basically tells you the likelihood of some event occurring, given that some event has already occurred. We'll explore that more in a bit of detail later on. The word naive in naive-Bayes classifier is there because it assumes that the presence of a particular feature is unrelated to the presence of any other features. To give an example of this, suppose that you have a naive-Bayes classifier and you are trying to classify something. Now you have four columns. One of them is date of birth, the other is age. Now it doesn't take a genius to figure out that the date of birth column is what's going to define the age of a person. So if the date of birth is 27th of May 1995, then the person's age is going to depend on that. If another column has the date of birth of 1st of January 1947, then that person is going to be older than the previous row. And all of this is defined by the date column. But we also have the age column, which could be derived from this. So as you can see, there's a strong correlation between the two. Now, the word naive in naive-Bayes is here because we, in the classification process, do not consider these two columns to be correlated with each other. If they are, then this could lead to a little bit of a performance downgrade because we have just not picked up on an important feature of our dataset or an important relation between two columns in our dataset. So when you're using naive-Bayes classifier, it is important to understand that the columns that you are trying to process using naive-Bayes classifier are not interrelated. They don't have strong dependence on each other. So if one column's value increases, the other column's value should not be affected by that. So this is why it's called naive. Naive basically means that we have a very small worldview of things, and this is what it means in naive-Bayes classifier, that we assume something to be true. Whether it is true or not, that's not particularly useful to us in this scenario. If you're trying to implement naive-Bayes, then we have to be the ones who need to ensure that the particular requirements of the naive-Bayes classifier are being met. And the word Bayes in the classifier is there because it is based on Bayes theorem, which uses conditional probability. So if you have ever studied probability in any bit of detail, you might have come across something called Bayes theorem. It's quite popular. It is a theorem in conditional probability that tells us the likelihood of an event occurring given that another event has already occurred. So let's take a look at understanding conditional probability. Conditional probability is the bedrock of the entire thing that we are covering. Naive-Bayes uses conditional probability quite extensively. So it's our job to figure out what conditional probability actually means. So let's try and understand the conditional probability. Firstly, calculating the probability of the second event, which is event B, given that the first event, event A, has already happened, is what's called conditional probability. If you have ever tried to calculate what is the likelihood of something raining, given that it has already rained the day before, so that's a conditional probability in which event B or the second event is raining today, and event A or the first event is the event that had happened previously. So if it had rained previously, then it would be yes, otherwise no. There are other examples as well, such as drawing a second ace from a deck of cards, given that we have already got an ace in our first attempt. So if you have a deck of cards, then how likely are you to draw a second ace given that you have already gotten an ace in your first attempt? This is important because once you get that ace, you don't put it back into the card to maintain the probabilistic nature of the card, random probability of getting card out of a deck. So after you have picked an ace, the probability shifts in some scenarios. So how does it shift and how does it help us is the first example. Secondly, finding the probability of having a disease given that we were tested positive. So if you have been tested positive in some disease, you treated it and you have been tested again, what is the probability that after the treatment, the test is going to come out to be negative or positive? What's the probability that you are going to have that disease even though you have gone through the entire treatment? Third thing is finding the probability of liking Game of Thrones given that a person likes fiction. Game of Thrones is a fantasy fictional world that is written inside a novel and has a TV show. What is the probability that you are going to or anyone is going to like it, given that they already have told us that they like fiction, they like fictional books? So these are some of the examples. Of course, we can come up with many more, but these are enough to get us started. So let us define the two events. Event A is the probability of getting the event that we're trying to calculate. Event B is the condition that we know, or it is the event that has happened. So we know something has happened and we want to know how that affects the probability of something else happening. So to give you an example, another example would be if you were trying to roll a dice. So if you have gotten some value out of a dice before, let's say 4, what is the probability of you getting that value again? It's going to be exactly the same because nothing has changed in that regard. On the other hand, what is the probability of you getting an ace out of a deck of cards once you have already gotten an ace in the first attempt? In this case, the number of cards changes, the number of aces in the cards change. So obviously the probability that we're trying to calculate is going to change as well. So this is where conditional probability comes into play. To put it more plainly, we use this notation in which we use P, which is a mathematical function to calculate probability, and we give it A and B, where A and B are used to define something, the probability of occurrence of event A given that B has already happened. So in this scenario, it would be P of, and instead of A, we would write getting a deck of cards, and instead of B, we could write gotten a deck of A's in the first attempt. So that's what conditional probability is. As you can see, you can look at the formula on the right hand side of the explanation as well. We write P of A by B, in which basically means that we want to calculate P of A and B. So P of probability of A occurring with B, and then the probability divided by the probability of B occurring independently. That's how you calculate the probability of event A occurring when event B has already occurred. Suppose we are given a jar containing 6 marbles. So assume that you have 6 marbles given to you inside a jar. 3 of these are black, the other 3 are red. So out of those 6 marbles, 3 are red, 3 are black. What is the probability of getting a black marble given that the first one was black? So let's say that instead of a jar, it was a bag. You have closed your eyes, you randomly put your hand inside the bag, randomly pull out a marble. The first marble that you pull out is the black one. What is the probability that you put your hand back into the bag and pull out another black marble? Because obviously the number of marbles and the number of black marbles have changed from 3 out of 6 to 2 out of 5. So let's take a look at that. So let's say the probability of A is getting a black marble in the first turn. So this is the event that has already happened. Then there's the probability of getting a black marble on the second turn. So obviously, since you were trying to get a black marble in the first turn, there were 3 black marbles out of 6 black marbles, so the probability is 3 by 6. On the other hand, the probability of getting a black marble in the second turn is 2 by 5, because now there are 2 black marbles out of 5 marbles remaining in the bag. We have not put the first marble that we took out of the bag again into the bag. So now if you want to calculate the event of getting a black marble in the second turn, given that in the first turn we have already gotten a black marble, this is how we do it. We multiply 1 by 2 into 2 by 5 and we get the answer 1 by 5. So this is what the probability algorithm states. So we get P of A and B divided by P of A. Given that, that's how we're going to calculate, and we get 0.4 out of the answer. Now let's take a look at an example of how naive Bayes would work. This was a very contrived example that we had taken, but now let's take a look at a bit more real world example where we have data, rows and columns in a data set. How does that work in our entire process? So we take a look at the example. This on the left hand side is the data set where we have conditions such as outlook, temperature, humidity, windy, and play. Play basically means that you have gone out to play, or you could also consider this as a team thing. So whether your team went with the decision of going out and playing given certain weather conditions. So on the dataset side, we have 14 rows and we have things such as outlook, temperature, humidity, and windy. And the class that we want to classify them into is yes or no. So 2 classes. So this is the data set. We have outlook, temperature, humidity, and windy, and play. This is a famous data set. It's been used quite a while with other algorithms as well. So we firstly calculate the total number of samples, which is 14, and we calculate the total number of yes and no. That's how we can calculate the probability of getting yes and no if we were to just randomly do this. So the same way, if you were to just randomly put your hand inside a bag and pick out a black marble or a red marble without assuming any changes or any event has occurred previously, it's the same thing here. Out of the 14 instances that we have recorded, 9 of those were yes, 5 of those were no. So let's create a frequency table of each attribute. So we have the outlook. In outlook, we have sunny, overcast, rainy. So we calculate the yes and no of all of those, and the total ones are 9 out of 5. For yes and no is for 5 times. So we get that for temperature as well. So hot, mild, and cool. We get that for humidity high and normal, and we get that for windy true and false. So after creating the frequency table, all we're doing is taking a look at all the yeses and nos and taking a look at each of the attributes and taking a look at the value of that attribute and figuring out how many times that value has led to a yes, how many times that value has led to a no, and then we just calculate the probabilities by creating the frequency table. So we take a look at all of this. Now we take a look at the probability of each attribute, which is basically total probability divided by the number of probability. So here we have it. Out we have 5 by 14, 4 by 14, and 5 by 14. On the other hand, in the temperature section, we have 4 by 14, 6 by 14, 3 by 4 by 14, and one by one we calculate this for everything. So what is the probability of these events occurring given that some event has already occurred? So we take a look at that. And finally, we calculate the probability of each event, which is yes and no. So we have already done that, P of yes and P of no, 9 by 14, 5 by 14. So that's the data that we need. So now we have to calculate the likelihood of each attribute. How likely is it that we're going to get one out of the other? So out of the 5 times that we got no, 3 of those were sunny, 0 of those were overcast, and then 2 of those were rainy. So that way we calculate the likelihood of each attribute, yes or no. And based on each of the attributes, their values, we calculate that. And now finally, we have to calculate an event of B occurring when an event of A has already occurred. Same way as we had done before, we calculate the probability of A occurring when B has already occurred by using the same formula, where we calculate the probability of A and B and divide it by probability of B. So by doing this, what we do is let's say we get a condition in which outlook is sunny, temperature is cool, humidity is normal, and wind is false. Here we are trying to calculate whether or not something we are going to go out and play. So we calculate the probability by doing this. We put the data into the formula, and the output we get is 0.029. So that's a low probability, and if we were to just if the value that we get out of it is low, that means that we are not going to go out and play. So we go out and we get the probability of yes and no. Probability of yes is 73, which is a high value, so that means that we are going to go out and play. So that's how we calculate the probability of yes and no. And now that that is done, let's take a look at some of the use cases. So Naive Bayes has several use cases. As you can see, we have spam filtering, news classification, emotion detection, face detection, and fact checking. In spam filtering, in Naive Bayes, what we do is we calculate the frequency of words and vectorize them. After calculating the frequency of certain words, we check whether or not it's a spam or not, and figure out how does the frequency match up with the thing being spam or not. So that's how you can calculate spam filtering. It is a really effective process. Many of the spam filtering mechanisms use Naive Bayes somewhere in their data science or machine learning pipeline. So it's quite useful. Then comes news classification. Suppose you have a news website where you want to, whenever someone posts some news, you want to aggregate and group it into a kind of genre. So whether it's a sports news, international news, finance news, a celebrity news, any kind of news, and you want to put them into certain categories. So if to do this automatically, you need to train a model. And this is where Naive Bayes also comes into play. As you can see, this is much more inline because in Naive Bayes, you get to use the natural language processing systems as well. And also you can take a look at the words and vectorize them. So textual data is very useful in Naive Bayes. Then comes emotion detection. You can perform this in two ways. Firstly, using images. So how does a person inside an image look like? Whether they look sad, angry, or something else. Similarly, you can take a look at the text information, such as in a review, whether a person looks satisfied or dissatisfied, whether they look angry or happy, something like that. So you'll take a look at the review of a person and you understand the context and understand how it works with them. Then there's face detection. It is not the same as face recognition. Face detection basically means we're trying to figure out whether there is a face inside an image, and that's what face detection means. Face recognition would mean that if there is a face, who is it? Is it someone we know? Is it someone unknown? Then comes fact checking. Fact-checking websites are far and few between, but many of those use naive Bayes in order to figure out whether or not some facts are given true or not, based on the intensity of the words that are being used and whether or not they have some links to other websites. We try to figure out how the fact-checking of the entire process goes. Let's have a hands-on in which we'll be using naive Bayes. I have a particular algorithm with me. I have Jupyter Notebook opened right next to me. Now I'm going to do is I'm going to import certain libraries. If you have Jupyter Notebook with you, you can import it yourself. Firstly, I'm going to import pandas. So let's just do that from import pandas as PD. This should look quite familiar to you if you have ever used pandas. Then from sklearn dot feature extraction dot text, and we are going to be processing a lot of emails. We're trying to create an email spam classification algorithm, a model. So we are trying to use something called count vectorizer. So let's just use, yeah. So we are trying to import count vectorizer from, so we get that. Now, after importing count vectorizer, we want to import the naive Bayes algorithm. Now in sklearn, there are multiple naive Bayes algorithms available for you. I'm going to import multinomial naive Bayes because it's the best one to work with in case of a text information. So data is in the text format. This is the best one to use. Another one we're going to use is pre-processing import label encoder. We'll take a look at why we're importing them one by one, and now finally import P. And now at last we're going to import certain metrics such as accuracy, score, and confusion matrix. So from learn.metrics import accuracy, I think I misspelled it, accuracy score and confusion matrix. I run this. Let me just run this again. So this will import everything that I need. It doesn't fail, so it works. Now let's get some data from the pd.read CSV function. Inside that function, I'm going to type in the name of the CSV file I have, which is spam.csv. In case you don't have that file, don't worry. We'll guide you through the resources which you can use it, but just understand how it works. So if I run this, it works, but I also have to pass in some encoding because it's encoded not in UTF-8 but in Latin 1 encoding. So just using encoding is equals to Latin-1 so that our data frame properly parses our CSV file. Now if we take a look at our data set, this is what it looks like, and as you can see it has some unnamed columns as well. This could be because some of the data was not collected properly or some corruption of data as we got along. We only need the label and the data, so we can drop these three columns, and if they had some value to us then we could have just encoded them, but right now dropping them would be better. Let us first take a look at data.isNull.sum. So as you can see, majority of the data in unnamed 2, 3 and 4 columns is not present, so we don't want to encode them, we just want to drop them. So to do that, pandas provides us with a really great function, df.drop. Inside it I have to pass in 3 column names, so I'll just pass them here: unnamed 2, unnamed 3, unnamed 4. These are the 3 columns that we want to drop. After dropping these 3 columns, we want to also make sure that we are passing in the in place parameter to be true. In place basically means that we are going to drop it inside the same data frame. If we didn't pass it, then it would drop the columns, make the copy of the new data frame in which the columns that we have specified is dropped, and return it back to us. So I run this. This works. Axis 1 basically means I want to drop columns, not rows. So you can drop rows and columns depending on the axis that you have provided. By default, the axis is 0. So now if I take a look at my data set, as you can see, only 2 data. So it has 2 labels, spam and ham. Ham means there is no spam, and spam means that this is a spam email. It contains some sort of a data or something, links that we don't want to use. So now let's split it into x and y columns. So x, y is equals to data.data, comma data.label. Run this. We have gotten the data. Now let's split them into training and testing sets. So x train, x test. y train y test is equals to train test is split, pass in x, pass in y, and now we need to pass in the test size. Test size defines how large of the portion we want to set aside for testing. In my opinion, we'll set 30% of it to 0.3. Run this. So the data has been split for us. Now we can use the vectorizer to vectorize our data set. So vectorizer is equals to count vectorizer. Now what this will do is that it will take our X-train values for our training set and will convert them into a frequency table just like we did previously. So all I have to do now is use the vectorizer dot fit transform, run this, and we have gotten it. If I take a look at the count, as you can see, it is a sparse matrix of class numpy.int. It stored 51,258 elements. So it's gotten all the words and the counts and how many times they have occurred. Now we need to make the prediction. So to make the prediction, I'll use ypred is equals to, and before this making a prediction, I need to create the classifier. So CLF is equals to multinomial naive Bayes. Inside the multinomial naive Bayes, I need to firstly create my targets. So, and finally, I will just have to fit my classifier using counts and targets. CLF dot fit counts targets run. Okay, count, not counts. Now it works. So our classifier is fitted. Now we need to make the prediction. So ypred is equals to CLF dot predict, and inside the predictions I want to transform my testing dataset. So vectorizer dot transform x test dot values, or if you don't want to pass in the values, you can just do it this way. This will work just as fine. After doing it, we have created the classifications that we needed. Now let's print the confusion matrix. Confusion matrix will need the y test and the y predictions. And we have gotten this. So majority of our predictions are correct. 16 plus 7 predictions are incorrect, which is around 23, which is fine. It's not that big of a deal given the size of the data set we have. Let's take a look at the accuracy score. And we have to do the same thing that we had done earlier, y test and ypred. Run this, we have an accuracy score of 98.6%, which is quite large. So as you can see, it was quite easy for us to use naive Bayes algorithm. If you want to implement these things on your own, you can, but since there is already a lot of libraries available for you to do this, we see no reason for you to have to do this on your own. So now let's take a look at how we can learn new things. So an investment in knowledge always pays the best interest is a quote that always helps me when I'm trying to learn new things. Keeping that in mind, we have a community site that is on the domain intellipaat.com/community, where like-minded people can help each other out. So if you want to learn something new and you are facing some issues, you can post your questions in that community site. People who are at the same transition path as you are can help you out there, and you can help others out as well. And also we have a blog, which is intellipaat.com/blog, which you can use, and we provide a lot of free content there. We cover topics ranging from data science, machine learning, cloud computing, career transitions, and a lot more. So you can take a look at that as well if you're interested in that. With that, we also have our YouTube channel, and on our YouTube channel, we provide a lot of free courses. We produce new content every day, so you can subscribe to that channel and take a look at the free courses that we have provided already. But if suppose you don't want to get free courses, you want to get certified. So to get certified, you can visit our website, and we provide a Masters in Data Science program, which will help you jumpstart your career in data science using Python or R, whichever language you prefer. So as you can see in this master's program, you get to learn data science with R, data science with Python, machine learning, AI and deep learning, data science with SAS, and a few self-paced trainings as well. And with that, you get to learn Excel, MongoDB, MS SQL. You don't just get to watch videos passively, you get to create 53 plus projects These are 10 plus courses with 232 hours of learning material. These are available to you forever. Once you purchase them, you get 24/7 support for lifetime. So if you have any issues regarding anything that we teach, you can contact us at any time you want. You get certification and job assistance. You get lifelong free upgrades. So if new course content comes along, and we will upgrade you for free. So you can take a look at an overview of each of the programs. Take a look at the testimonials. It's one of our highest rated courses. Take a look at the course content. If you are interested into learning more, you can take a look at the course content and understand what we teach. You can take a look at the certificates that are available for you once you complete masters in data science. These are the two certificates that you get. One is accredited from IBM. The other one is from Intellipaat, as certifying that you have completed the course. These certificates are valid in many multinational corporations ranging from Nasdaq, Ericsson, Sony, Cisco, and a lot more. You can take a look at the FAQs in order to get a better grasp of any question that you have. In case your questions are not answered in the FAQ, let me guide you through a resource through which you can get your questions answered. But before that, thank you so much for joining us. This is a coupon code, especially for our YouTube viewers. You can get 30% flat off on any of the courses that we provide. This coupon code is available for a short period of time, so we recommend that you make use of it as quickly as possible. Now, with that in mind, we have come to the end of the presentation. We have discussed all the courses that we can in order to help you get started. You can take a look at the numbers on the screen in case your questions were not answered in the FAQ. You can contact us via email as well on the email that is mentioned on the screen. Our course advisors are there to help you out 24/7 to help you understand a career trajectory that would be most beneficial for you. With that, we have come to the end. Thank you so much for joining us, and we'll see you next time.